Welcome to the Asian Coding Interview series by Paul Fruitful. In this season, we'll be focusing on data structures. Grab your popcorn and stay tuned. Welcome to another episode on the Asian Coding Interview series. So we'll be looking at the singly linked list. Before we start the implementation, like the coding of this data structure, I would like to give you a visual representation of it, so you have a mental picture of what we are doing, so you can easily understand what is being implemented during the live coding section. So stay tuned and grab your popcorns. The definition of the singly linked list. Okay, in the previous episode we explained the different types of linked lists and we defined them, but you can take this more like a revision. A singly linked list is a linked list with each of its individual node having a pointer to the next node. So because of it has only one pointer, it is called a singly linked list because each pointer is just single. So the next thing we'll be looking at is like the visual representation of what a singly linked list looks like. So stay tuned and keep watching. Okay, so this is the graphical representation of the singly linked list. So if as you can look closely in the image, the head, which is the embodiment of all the whole collection in the singly linked list. It contains every node in the singly linked list, and you can see that each node has a next pointer to the next node, and it goes from the left to the right, and the last node points to null because null is the base at the initialization of every single linked list. The head is assigned to null, to a value of null, so that's why the last node points to null. So if you didn't watch the last episode, I advise you to watch it because it explains this graphical representation in details of every linked list, every type of linked list. So you can go back and go and watch it. So next up, we'll be looking at the visualization of the implementation of a single linked list. So stay tuned. Now we are going to be implementing we'll be explaining the implementation of the single linked list. So here we'll be explaining each single step it takes to implement a single linked list, and we'll be using pseudocodes. Yes, we'll be using pseudocodes to represent each method, each class, each object, and everything technical, so that you can now implement the single linked list in your preferred programming language. So stay tuned and watch how it goes. Before you start any implementation on the single linked list or any linked list, it's best that you create a class for your node objects. Yes, so that class is what regulates the attributes and the behavior of each individual node in the linked list. So that node class is what is going to contain the value attribute which contains the value of the node, the next attribute which contains the next pointer, and the index attribute which contains the node's index. So this node class is very important because it's what regulates that node object. So here is pseudocode of what a node class should look like. So you have to implement this pseudocode in your preferred language. So as a pseudocode is more like a code written without any language syntax, like an imaginary code, or trying to paint a picture here with a code. So this pseudocode right here is trying to show you what a node class should look like. So if the class is declared, this is the function called at its initialization. So it takes in three arguments: the value, the next, and the index. So it sets the value attribute to the value argument, it sets the next attribute to the next argument, and it sets the index attribute to the index argument. So next up we'll be looking at more interesting things. After making the node class for the node object, the next class you need to make is the singly linked class. So this is the class where the real stuff happens. So this class regulates how the collection is managed. It's what houses all the node objects are going to be involved in the singly linked list, and it's also what gives each of the node an index, and it's also what instantiates that node object. So here's a pseudocode representing the first stage of the singly linked class. So we start with the first function, that's the initialization function. So this is what happens when this singly linked class is initialized. The head, that list of head, if you look at that diagram, that head is what contains all the nodes or all the elements of the linked list. So it is initially set to null, and the length of the singly linked class is set to 0. So we'll be looking at the insert function next, and it is the insert function that adds nodes into this head attribute. So still stay tuned and keep learning. Okay, so this is the insert method. So this insert method is what puts in nodes inside the singly linked collection. So it takes in the value that it wants to insert, then it creates an instantiation of the node object, as you can see, and it fills in the node object with attributes. First off, it stores the node instantiation inside a variable called the node variable, and you can name it anything you want, but I call it the node variable. So it fills in the node object with all the attributes it needs. First, the value attribute. It fills in the value attribute with the values to be inserted. Then the next attribute, it fills it in with the current head, the current state of the head. Then the index attribute, it fills it in with the length of the singly linked collection. Then it updates the head by giving it by assigning it the node variable. That means it gives this object instance is going to be the new head, and then it increases the linked list length by 1. So if you didn't just get this explanation that I did now of the insert method, there's a clip after this one which is going to give a practical explanation of this insert method. She's going to explain it with a live practical. So still stay tuned. Okay, so in this slide, we are going to be focusing on explaining the insert method with a practical example. So let's say we have an empty linked list and we want to add these two values into the linked list. Let's say it's 1 and 2. So how does the insert method how does the insert method store it in the singly linked list? So we'll be having a walkthrough from the pseudocode. So I advise you can also write the pseudocode in the paper because we are going to be using it to explain it. So look at what the insert method does. Having a node class, the node class already instantiated. So the first the first um the first thing to be inserted will be actually 1. So remember that node variable which has the instantialization of the node object. So it's going to just take that value because 1 is the first one we're inserting, so it's going to have that 1 value. Then the next, which is the current head, is null. So here is going to be null. And the index, which is the current length, is going to be 0. So with that being done, so then the next thing is the current head which is null at the moment, is going to be updated to this new node. So it's going to look like this, something like value is equal to 1, next is equal to null, index is equal to index is equal to 0, something like this. And then the length of the linked list is going to be updated. So the length will be updated plus 1 because it was 0, something like that. So in the next insertion, which is 2, the head is no longer null. This is what the head is. The head is this. This is what the head is at the moment. This is what the head is. The head has 1 as its current value, and then the next head dot next is null, and the index is 0. So when we are inserting to look at what's going to happen. The node, a new node instantiation will happen now, which is going to have 2 as 2 as the new value of this new node object. Then the next of these 2 is going to be this current head, and the index is going to be the current length, which is 1, something like this. And then after that, the head is going to be equated to this new node object, which looks like this: node value 2. Then this is where it gets tricky. The next is going to be this previous the first node we inserted, which is 1, which was the previous current node. So it's going to be this. The next will be also another node object, that previous node object. So the next is going to look something like this: node value 1, next null, index 0, and then that's it. Then the index of the current head is going to be, the index is going to be 1, because remember the current length was 1 when it was inserted, so it's going to be 1, and that's it. And the same thing goes on for the rest of it. So if you're adding 3, this one is going to come down, and 3 is going to be the current value, and it's the pattern keeps going on. So I hope this example explained how the insert function works. So the next thing we'll be looking at is the get node function. This function is not that compulsory for the simply linked list to function. I just prefer to add it because it helps me in a lot of manipulations. So still stay tuned. Okay, so this is the get node method. So what this method actually does is that it fetches individual nodes from the singly linked list by its index. So let me run through the pseudocode and explain how it works on the ground. So first it creates a copy of the collection, then it uses a while loop to keep on traversing the collection as long as the copy is not null. So if it finds any node with an index attribute that is equal to the index to be found, it returns that node. Else it moves on to the next node, and it keeps on moving on to the next node till it gets to null, because the last node in the singly linked list is null. And if it doesn't find, it returns false. So it's as simple as it gets. So the next method we'll be looking at is the check method. So just stay tuned. Okay, so the check if exist method. Okay, the purpose of this method is to check if a certain value exists in a collection of a single linked list. It's similar to the get node method, but this one doesn't return a node. It returns a boolean which is either true or false. So it follows the same procedure for traversal through the linked list. So it creates a copy of the collection. Then it uses a while loop to check if the copy is not null, and it keeps on traversing till it finds a value that is equal to the value to be found. And if it does find it, it breaks the loop and returns true. But if it doesn't, it keeps on going to the next node till it gets to the last node, which is null. And if it doesn't find anyone before it gets to null, that means it's going to return false. So it's that simple. So the next method will be a little bit tricky, and that's the delete method. Here we are going to be writing another method inside the load class and the singly link class. So it's going to be interesting. Okay, so this is a print method, and as its name suggests, it's just used to print every node in the singly linked list collection. So it will just is similar to the get node and the check if exists node. It uses the same mode of traversal, but the thing here is that it doesn't take any argument, that there's no condition to break the loop. So the loop has to get to the last node and print every node to the last node, and it's pretty straightforward. So makes a copy of the collection, uses a while loop to keep on traversing the linked list as long as the copy is not null, and keeps on printing each individual node by copy.value. We print it, then goes to the next one and print, and keeps on running till we get to the last element inside the linked list, which is the null value. So it's just pretty straightforward. So in the next slide, I'll be showing you, we'll be doing some like practicals. We'll show you with a Python implementation that I made. And also, you may also choose to print something more graphical, like more graphically interested, like using objects, decoration, arrows, and different things. Like in my implementation, I made it to be more, I decorated it more, I made it to be more beautiful. So still stay tuned, and I hope you're understanding what we are doing here, because it seems pretty complex at first, but you will still get a hang of it if you keep pushing. So this is my Python implementation of the singly linked list data structure. So here you can see everything I wrote in the pseudocode, but it may look more complex and more complicated. So this is the node class, the initialization method of the node class, the attributes, the delete helper method for the help for the remove method in the singly linked list class, and all of it, the insert method, the check if exists method, the get node, the remove method, the print method, all of them are just here. So we'll be testing each of them with this collection. So I inserted 10 values into the singly linked list. So we'll start with the print method. So let's look at what the singly linked list looks like when I use the print method. And like I said, you can make the print method of your own implementation more beautiful, like decorate it more, like I decorated. But when I didn't want it to be just basic and minimal, I just wanted it to look fine and attractive in the eyes, like an object. So you may be asking, why didn't I use JavaScript? Because there are a lot of JavaScript developers watching this video. Like I said at the beginning of the video, I wanted to use JavaScript, but I prefer using Python for stuff related to data structures and algorithms. Though I'm going to still make a JavaScript implementation, a JavaScript variation, and I'll put it on the data structures repo on my GitHub. So I'll put the link in the description so you can check it out. So let's start with the print method. Let me enlarge my terminal so you can see it easily. So see, this is what the print but it printed all of them like an object. You can see the last node inputted was 12 and its index is 9, and the next one is 37, which is this one. The next one 38. Beautiful. Then the first node, which is also the last node, if you look at it from the code perspective, it has the index of 0 and its next is null, as it should. So that's the print method for you.
and that's how I decorated it to be like. So we are going to check the next one. Let's do the remove method, or let's do the check if exists method. So test check if exists. Let's check if exists 3, if 3 exists in this collection, and still increase the terminal. Also, the way I did this is that, okay, let's go. Okay, I forgot to add my print statement here because normally it's just going to return a string, and if we don't print it out, that's the way I wrote it. But maybe in your own implementation it might vary. So that's found, but it returns found. But if you write 113, it's going to return not found. Not found. So we can also use the get node method. As remember, the get node methods returns a node by its index. So we use the index of, let's say, 4, and let's print the value too, so that it will show 43. That's the node with the fourth index, so it's 43. So that's it for the get node method. So let's check the remove method. Let's remove the third, the node with the third index. Okay, that's the fourth node. Okay, and then to check if the remove method work, we're just going to print it. My aim at these videos is to make them short and concise and explanatory so that people can easily get insight from them. Oh, we have an error. Oh, we have an error. Wait, let me get it. Get index. Oh, I forgot to rename the get node at the okay, I forgot to get node, not get index. Before I made this video, the name of that method was get index. So I try to make it clear. Okay, so let's get and read on. So we are going to test the remove method. So we are going to remove the node with the third index, and that node is 33. So after the remove, after applying the remove method on the collection, we'll check if it exists. So let's run it. And oh, I forgot to print. I'm always forgetting to print it. And okay, that is done. So not found, meaning that the remove method is working. So implementing the single linked list is not that hard, depending on the language you're using. And like I said, I prefer Python because I'm more flexible with Python for things like automations, data structures, algorithms, and machine learning. So I believe Python is the best for it. So some people may argue that JavaScript is better. That's your own preference and that's your own opinion. So I hope that you understood what happened in this video, every process, every procedure. And if you don't, I advise you to rewatch the video with a slower time speed so that you can easily understand what happens. And I'll see you in the next one. Thank you. And don't forget to check the description for helpful links and helpful resources to help you ease your journey on understanding data structures.
Thank you for watching the video. I'll be leaving links to helpful resources to get you grounded in these concepts. I will be releasing a video every Friday, so click the subscribe button and stay tuned. Peace.